3. Hi, I am Jay Dharanidharan. Today we are going to see a topic in mathematics, a simple topic, probability. A probability is a branch of mathematics which deals with the occurrence of an event. Probability is a prediction that an event can happen or not happens. The value, numeral value of the probability lies in general between the 0 to 1s. Since it is a prediction of events which occurs in our life. In formula, probability can be defined as it's a ratio between the number of favorable events and to the total number of outcomes of the events. As of probability is defined as P of set A. It's a probability of a event. So a probability can be a numeral like decimals or in a percentage, but probability cannot be in negative form since there is no negative values for the probability. And probability can be examples like we can give many examples of probability equally likely events where we can have in a dice example. We can in a dice we have a probability of getting 5 and probability of getting 6 is equal, so the probability is equal and like in these events. And probability of complement events, where we can get a probability of a event is equal to the probability of a complement event plus probability of event is equal to the 1 unity. For getting a complement of the event, we want to subtract uh, probability of the event 1 minus p of the a or events, probability of the event, so that we can get the complement of the events. And impossible events which cannot be happen in our lives, it is the impossible events, so probability of the impossible events is generally 0. And so that probability of impossible events, example, probability of going to death is 0. And mutually exclusive events where the probability of events is 1, where in coins we have probability of getting heads and probability of getting uh, tails is equal to 1, where probability of a plus probability of b is equal to 1. So it is a mutually exclusive events. And also in examples of Venn diagram, probability of uh, a intersection b in the mutually exclusive events is 0, so probability of a intersection b in this is 0. And also in addition rules, probability of a union b is given in the Venn diagram form, probability of a plus probability of b minus probability of a intersection b. In this Venn diagram we can see probability a when circle and probability of b circles are and probability of a intersection circles, which is in between the a and b. Probability of a union b is given by probability of a plus probability of b minus probability of a intersection b. And also complementary, in complementary angles, as I told before, uh, probability of a in complement is given by the 1 minus probability of event a. uh, uh, Now we can see a small example in the probability. Probability of getting a head in the tossing of coin is probability of getting a head in the tossing of a coin is always 0.5. Since it's a mutual event, probability of getting tail will be 0.5 and probability of getting head will be 0.5. So in mutual event, 0.5 plus 0.5 is equal to 1. Probability of head plus probability of tail is equal to 1. So it's a best example for the mutual events. So next we can see a small example with the probability using alphabets. Probability of getting a vowels in the present alphabet list is can be given as we want to identify as given data, so we want to identify the probability of vowels in the occurrence of the alphabetical letter. Total number of alphabet letters are 26 and total number of vowels are 5. So probability of getting vowels is equal to number of vowels divided by now total number of alphabets. So we know that vowels are 5, so 5 and divided by total number of alphabets 26. So the event of probability of getting vowels in this event is 5 by 26. 1. Another examples using balls. The Totally we are given three red color balls and five white color balls, and probability of getting uh, three red color balls is identified by using formula method. Given data, total number of balls 5 plus 3 is equal to 8, and we want to event of occurring red balls is 3. So probability of getting red balls is equal to number of red balls divided by total number of balls. So number of red balls is 3 to divided by total number of balls is 8. So 3 by 8 is the event of getting red balls.
Start.
Now we can see a last example using number sets. And number of in a set number 10, it contains 10 numbers, where it from 1 to 10 we can like 1 2 3 4 5 6 7 8 9 and 10. This is a whole set, and probability of getting a even number in this set is we want to be identified. So in 1 to 10 there are 5 even numbers like 2 4 6 8 and 10, and in 1 to 10 there are 5 odd numbers like 1 3 5 7 9. In many of the mathematical concepts, one is depends on prime or non-prime numbers like that, but it's a odd number. So we can see that probability of getting an odd number in this set is it given by the number of odd numbers divided by the total number of numbers in this set. So it's 5 by 10, it's 1 by 2, 0.5 is the probability of getting odd numbers. It's same to the probability of getting even numbers. Same 5 numbers are even numbers in this set. So probability of this getting even number in this set is 0.5. So it shows that it is a mutual event, where probability of getting a odd number and probability of getting a even number is summed, and it gives a value 1. So it's a mutual event. And also in general, in experimental, all the sum of all the events in the set is equal to 1. So this is also an example, and this is a best concept where we can easily identify, and it can applicable in our latest lives. So it is a very easy concept, so we can see it in further. Thank you for listening it. Thank you.